Both a VPN and firewall can be great additions to any home, lab or office networking, providing more security capabilities and remote access to trusted peers. But in certain situations, like dynamic IPs or shared Wi-Fi, the setup can be a bit more involved and you can spend ages browsing the web to find something completely suitable. But for less than £50, here's a solution you can build that's reasonably energy efficient and greatly expandable. Consuming about 25 watts at idle, its power draw is higher than the ARM-based OpenWRT competitors, but if you're like me and you have some parts lying around, this can further offset that cost. And I only had to buy the small form factor tower, which came in at £27 from an eBay seller, and you can't go too far wrong at that price. So let's start with the unboxing, go over all the ins and outs, what the spec of the machine is, and the devices that I'm adding to it. To my surprise, the item came in its original shipping box, looking like it had just been delivered from HP themselves, and there were only a few signs that the item was used. The seller included a standard kettle cable, which was fortunate as I never seem to have enough of these. The chassis is bigger than what I thought, and that's something you trade for expandability. It's still small enough that it should not pose too much of a problem for placing in sight, and it's a fairly inoffensive character. Nothing to write home about in the design, and not going to win any awards, but I appreciate the sensible and strong range of I/O, both modern connectors and legacy ones, such as PS2 and Serial. All it needs now is an out-of-band management interface, and that would really set it apart. Moving on inside, we can see we have a 200 watt platinum rated power supply, just the one fan visible and the other hidden in that supply, helping towards our energy efficient goal. At the heart of the system is a Bristol Ridge AMD Pro A6 9500 APU, launched in September 2016 and produced by Global Foundries. It's a 28nm production node, so a little bit old, but supports DDR4 up to 2400 MHz. The use of DDR4 here is important, as it reduces our power consumption by around 30% per DIMM over DDR3. And as this is an APU, there's some Radeon graphics built right in, capable of driving a couple displays and playing some very light gaming for accelerating some media workloads. It's by no means a particularly powerful system by today's standards, but for general computing and as a firewall, it far out succeeds minimum requirements by PfSense. If you were to drop in a higher end processor supported by the board, you could consider virtualizing the firewall and running it as a desktop OS alongside, if needs be. So in my configuration, I'm utilising 2 of the 4 expansion slots to add wireless capabilities and 4 more network interfaces, as I was unsure if the inbuilt NIC would be supported in PfSense. It turned out it was anyway, being a Broadcom device. The wireless is an old 802.11n card that I actually got for free in 2014 from Novatech, and was also fortunately supported, only up to G speeds in PfSense, which is pretty slow but more or less my broadband speeds. If you require much faster speeds, be better pressed using a wireless bridge or repurposing some old routers. This obviously costs more to do, but along with better speed you could reduce congestion if you work on the less widely used spectrum, such as Wi-Fi 6 or 6E. I needed the Wi-Fi as the internet is provided over a shared router, and from using the wireless card as a WAN interface, known as wireless WAN, PfSense makes this very easy to do fortunately. And the additional 4-port gigabit NIC was cheap and capable, costing just £11. This is a popular HP 331T. And just like the integrated NIC, it's also based on a Broadcom controller, with support for some more advanced features such as VLAN tagging and advertising low power consumption for high sustained throughput. For storage, I have an old 120GB SSD, which should be fairly power efficient and not contribute to any unwanted noise. Furthering that, you'll see I unplugged the optical drive, which is just a standard laptop one, but I did this in the hopes it might save a small amount of energy and again reduce any noise. You could though make better use of this slot by getting another adapter to mount an SSD or similar expansion. Right then, so to install the OS it's pretty straightforward. All we do is download the latest image from PfSense, the Community Edition, and we use Rufus or some similar tool to then burn the image to a disk, or better yet, a fast USB stick. We can then boot off the USB and follow the installation instructions, setting up our temporary interfaces and IPs for management. And once everything's configured, there's no need for the screen or any peripherals, and we can find a nice place for it. All of the management can then be done over the web GUI. If you'd like to see more on this, how I set up wireless WAN, firewall rules, and added Tailscale VPN, let me know in the comments below. Bye now.